Welcome to the session on trigonometric identities and equations. Trigonometric equations. The objectives for this session are to solve simple trigonometric equations of the form sine theta equals k and cos theta equals k, with k between -1 and 1, and also tan theta equals p, where p is a member of the real numbers. We're also going to solve harder trigonometric equations of the form sine n theta equals k, cos n theta equals k, and tan n theta equals p, as well as equations of the form sine theta plus alpha equals k, cos theta plus alpha equals k, and tan theta plus alpha equals p. We will begin with a review of the sine curve, which looks something like this. The maximum of sine occurs at 1. Sine theta equals 1 when theta equals 90 degrees, 450 degrees, and so on, every 360 degrees, in other words. And the minimum of sine is equal to -1. Sine theta equals -1 when theta equals -90 degrees, 270 degrees, and so on. Let's also review the cosine curve. This looks something like the one you can see on your screen now. Cos theta equals 1 when theta equals -360 degrees, 0 degrees, 360 degrees, and so on. And the minimum of cosine is -1. Cos theta equals -1 when theta equals -180 degrees, 180 degrees, and so on. We will also review the tan curve. The tan curve looks something like this, and it has no maximum or minimum. Tan theta is undefined when theta equals -270 degrees, -90 degrees, 90 degrees, 270 degrees, and so on, every 180 degrees essentially. And the curve approaches the asymptotes here as shown. We are going to begin by solving simple trigonometric equations of the form sine theta equals k and cos theta equals k for k between -1 and 1, and tan theta equals p for p in the real numbers. Notice that the solutions of sine theta equals k and cos theta equals k only exist when k is greater than or equal to -1 and less than or equal to 1, and also that the solutions of tan theta equals p exist for all p in the real numbers. Pause the video and have a go at this example. When you are ready to view the solution, press play. So let's solve this using one solution method. We are required to find the solutions of the equation cos theta equals 1/2 in the interval 0 less than or equal to theta less than or equal to 360 degrees. Recall the cast diagram. In the first quadrant, sine, cos, and tan are all positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. Now, from your memory or from your calculator, you will be able to find that theta is equal to 60 degrees. However, there are other solutions in this range. Theta equals 60 degrees is called the principal solution. Remember that the only quadrants which give a positive value of cos theta equals 1/2 are the first and fourth quadrants. So we have another solution as shown. Therefore, theta equals 300 degrees, or 360 degrees minus 60 degrees, is another solution, as shown. Let's now take a look at the other method. Again, from your memory or from your calculator, you will find that theta is equal to 60 degrees. However, there are other solutions in this range. Here's a sketch of cos in the range 0 to 360 degrees. There are two solutions for y equals a half in this range, as you can see from the diagram. One is at 60 degrees and one is at another point. In order to find the other point, we need to firstly observe that the curve is symmetric. And therefore, theta is equal to 300 degrees by symmetry of the graph. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. In this example, you're required to find the values of theta in the interval 0 less than theta less than or equal to 360 degrees that satisfy the equation sine theta equals cos theta. So let's solve this. Now sine theta equals cos theta implies that sine theta over cos theta equals 1. Of course, we've simply divided by cos theta. And therefore, tan theta is equal to 1. However, from our calculator or from memory, we know that tan inverse 1 is equal to 45 degrees. Let's go back to our cast diagram. The only quadrants which give a positive value of tan theta equals 1 are the first and third quadrants. So either we have 45 degrees here, which is the principal solution, or we have 45 degrees as shown here. However, this angle is actually 225 degrees when measured anti-clockwise from the positive x-axis. So 180 degrees plus 45 degrees, 225 degrees, as shown in the diagram. We are now going to solve more tricky trigonometric equations. Sin n theta equals k, cos n theta equals k for k between -1 and 1, and tan n theta equals p for p in the real numbers. Let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We are required to solve cos 2 theta equals a half in the interval 0 less than or equal to theta is less than or equal to 360 degrees. Begin by letting x equal 2 theta and then solve. So cos x equals 0.5. Since x is equal to 2 theta and theta is between 0 and 360 degrees, we have that x is between 2 times 0 and 2 times 360 degrees. So the interval for x is from 0 to 720 degrees. Now the calculator gives us that cos inverse of a half is equal to 60 degrees. And of course this is our principal solution, and we know that there are other solutions in our interval. Therefore, x equals 60 degrees, which is in the first quadrant, leads to other solutions as well. So here's 60 degrees as shown in the diagram. And of course, because we're investigating cos, and we're investigating cos of something equals a positive value, we're looking in the fourth quadrant because that is where cos is also positive. So our first principal solution is 60 degrees, and then another solution is 300 degrees as shown. And the other solutions are simply adding 360 degrees onto these first two solutions. So 420 degrees is 360 degrees plus 60 degrees. And 660 degrees is 300 plus 360 degrees. We can't have any more solutions because they will go outside the range for x. And so 2 theta, because x equals 2 theta, is equal to 60 degrees, 300 degrees, 420 degrees, and 660 degrees. And so dividing through by 2 gives us that theta equals 30 degrees, or 150 degrees, or 210 degrees, or 330 degrees. We are now going to solve more difficult trigonometric equations, such as sine theta plus alpha equals k, cos theta plus alpha equals k, for k between -1 and 1, and tan theta plus alpha equals p, for p in the real numbers. So let's take a look at an example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to solve sine x plus 30 degrees equals 0.4 in the interval x between 0 and 360 degrees. As previously, we let x equal x plus 30 degrees. This is the complicated bit in brackets. And then we solve. And therefore, sine x equals 0.4. Let's take a look at the interval for capital X. Since x, or rather capital X, is equal to little x plus 30 degrees, then we have the interval for capital X is equal to 0 plus 30 degrees to 360 plus 30 degrees. And therefore, capital X goes from 30 degrees to 390 degrees. Now sine inverse of 0.4 equals 23.6 degrees. You can find this from your calculator. This is the principal value, and it is not in the interval. Because clearly capital X goes from 30 degrees to 390 degrees. And therefore the other values are 180 degrees minus 23.6 degrees, which is 156.4 degrees, and 360 degrees plus 23.6 degrees, which is 383.6 degrees, as you can see from the graph. So little x plus 30 degrees equals each of these values. And therefore little x is equal to 126.4 degrees or 353.6 degrees. Let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve this. We are required to find the values of theta in the interval 0 less than theta less than or equal to 180 degrees that satisfy the equation sine 4 theta equals 3 cos 4 theta. So again, let capital X equal 4 theta and then solve. Sine x equals 3 cos x implies that sine x over cos x equals 3. Of course, here we've simply divided through by cos x. Therefore, tan x equals 3. However, from your calculator, you can find that tan inverse of 3 equals 71.6 degrees. The only quadrants which give a positive value of tan x equals 3 are the first and third quadrants. And therefore, looking at our cast diagram, capital X equals 71.6 degrees, as shown, or it equals 180 plus 71.6 degrees. So we have two solutions so far for capital X. Let's double check that these lie in the correct interval for capital X. The interval for x is 4 times 0, because theta starts from 0, and x is 4 times theta. So 4 times 0 is less than or equal to x is less than or equal to 4 times 180 degrees, because 180 degrees is the maximum value for theta. And therefore capital X goes from 0 degrees to 720 degrees. So we can find the other values or other solutions for capital X in this range. If we add 360 degrees to 71.6 degrees, we obtain one other solution, which is 431.6 degrees, and similarly for the other solution. We add 360 degrees to 251.6 degrees to give us 611.6 degrees. Let's reintroduce our theta. Because x equals 4 theta, we have that 4 theta equals each of these four values. So dividing through by 4 gives us theta equals 17.9 degrees, or 62.9 degrees, or 107.9 degrees, or 152.9 degrees. So this brings us to the end of this session. If you have understood its contents, you should be able to solve trigonometric equations of the form sine theta equals k, cos theta equals k for k between -1 and 1, and tan theta equals p for p in the real numbers. You should also be able to solve harder trigonometric equations of the form sine n theta equals k, cos n theta equals k, and tan n theta equals p, as well as trigonometric equations of the form sine theta plus alpha equals k, cos theta plus alpha equals k, and tan theta plus alpha equals p. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.